Artificial intelligence is growing fast, but the next bottleneck in the AI economy may not be talent. It may not be data. It may not even be chips. It may be electricity. AI systems are computationally expensive. Training large models requires thousands of high-performance processors running for long periods of time. And once models are trained, serving them at scale to millions of users requires constant compute, constant cooling, and constant power. So AI doesn't just consume energy once. It consumes energy continuously. That turns AI into a physical infrastructure story, not just a software story. This is why data centers have become the real factories of the AI era. They are the production sites where intelligence is generated and distributed, and factories need electricity, a lot of it. Modern AI-focused data centers can draw as much power as small cities. And as more companies deploy AI into search, customer service, analytics, video generation, and enterprise software, the demand curve climbs. The problem is power grids don't scale at the speed software scales. New generation capacity takes years. Transmission upgrades take years. Permitting takes years. Even connecting new data centers to existing grids can be slow, expensive, and politically complicated. So we're entering a world where AI capability is limited by a constraint that tech companies don't fully control: electricity supply, grid capacity, and physical infrastructure timelines. This is already changing corporate strategy. Technology firms are no longer competing only on models and products. They are competing on power access. Where can they build? How fast can they connect to the grid? Can they secure long-term electricity contracts? Can they guarantee stable supply at predictable prices? The answers to those questions shape where AI infrastructure concentrates, and concentration creates advantage. If one company can secure power and build compute capacity faster than others, it can train bigger models, deploy faster, and price more aggressively. Over time, that becomes a moat. But energy constraints don't just affect companies. They affect regions and countries. Some places can build faster because they already have excess generation capacity. Others struggle because grids are congested or aging. In many parts of the world, electricity demand is rising from multiple directions at once: AI data centers, electric vehicles, industrial electrification, heat pumps, and building electrification. Even cryptocurrency in some regions. All of that competes for this same infrastructure, which means AI is entering a world where energy is becoming strategic, not just operational. That's why we're seeing renewed interest in baseload power. Renewables are expanding rapidly, but they are variable. Data centers need reliability. They can't go offline when the wind stops or clouds roll in. So companies are increasingly looking for stable dispatchable power, hydro where it exists, gas peaker support, and in some cases renewed attention to nuclear. Not because it's trendy, because it's stable. And stability matters when your business depends on always-on computation. There's also a cost dimension. Electricity is a major operating cost for AI infrastructure. If power prices rise, the cost of running models rises. That can affect the economics of AI services. Some AI products will remain valuable even if costs increase, but others may become less attractive if margins compress. This creates a competitive separation. Firms with cheaper power contracts and more efficient infrastructure can sustain scale. Firms with expensive power and inefficient stacks may struggle. This is another reason AI advantages may concentrate. Now add a national security lens. Countries increasingly view AI capability as strategic. But strategic capability requires physical infrastructure. It requires data centers. It requires chips. And it requires power. If a nation cannot expand electricity supply reliably, it may struggle to scale domestic AI capacity. That creates dependency. Dependency on external cloud infrastructure. Dependency on foreign platforms. Dependency on external compute, which becomes geopolitical leverage. So the AI energy problem is not just about cost, it's about competitiveness, it's about sovereignty, it's about industrial capacity, and it's about who can scale. Over the next decade, the AI race may be defined as much by kilowatts as by algorithms. The biggest models and the fastest deployment cycles will go to the organizations that secure power first. And that changes the entire story of AI, because it means the future of intelligence is tied to the physical realities of energy grids, concrete, permitting, transmission lines, generation capacity. Not just code. AI is often framed as a digital revolution, but digital revolutions still run on electricity. And if power becomes scarce, the winners will be the ones who planned for scarcity first. That's the AI energy problem. and it may be the next major constraint shaping the global economy.